Hello students, welcome for today's session. So in today's session we are going to study about the series of the numbers like your arithmetic progression, geometric progression, all these series. We are going to see how to write a JavaScript program for that.
Hey guys, welcome to our next JavaScript challenge. And the name of this challenge will going to be math sequences, where we will going to have the function. And as an argument into the function, we're going to pass an array with a set of numbers. And if those set of numbers, we're going to be having the arithmetic pattern, which in the first case would be, let's say, 2, 4, 6, 8. As you can see, each and every value is being increased by value of 2. Or we're going to be checking for the geometric, which would be in this case, let's say multiplied. So we have 3 multiplied by 3, that would be 9 multiplied by 3 again, that would be 27. And the last one, if there's no pattern whatsoever, we're just going to return a -1. So if I'm passing 2, 5, 14, and 89, there is no pattern. So this will going to return a -1. Now, one thing that we're not going to be working on is the negative numbers. So I'm assuming that we're not going to pass here any negative numbers. That's how I'm going to work on this solution. And basically, again, yeah, so we're going to be working on arithmetic, geometric, or no pattern. And why don't we start doing that? So as you can see, I named my function math sequences. And here I'm just calling this function. And as a argument, I'm passing here this array, which will going to be eventually, again, some set of numbers. And at the moment, I'm not doing anything. I'm just going to returning the array that I'm passing in. And I guess we can start working on it. If you want to work on your solution all by yourself first, you can obviously pause the video and resume it once you're come up with your own solution. So first and foremost, I'm going to create 2 new arrays. So I'm going to say, all right, I would want the arith array. This is going to be for arithmetic differences. And at the moment, this will be going to be array. Now, later on, I'm going to transfer these into sets, the set data structures, because this is how I'm gonna use it for solution. Now the second one is going to be geo, which would be for geometric numbers. And again, at the moment, this will going to be a empty array. And now I'd want to set up the for loop. So I would want to loop through each and every array that I'm being passed in. However, the difference will be in the for loop, I'm not going to start with 0. So I'm going to say let I is not equal to 0, but it will going to be equal to 1. And you'll see in a second why I'm doing this. Then I'm going to be looping, obviously, through the whole array. So I'm going to say loop till you get to the array length or less than array length. And let's just pass length properly because usually I misspell that. And then let's write I++. Now, the way I'm going to do that, since I'm starting from the 1, so let's say from the first array, I would not start for 2. I would start with the value of 4 because we know that arrays are 0 index based. What I would want to do is I would want to check a difference for arithmetic sequences. So now I'm going to say, all right, so if I grab the index number 1 and I subtract whatever I have in the index 0, what is going to be my value? Well, the value would be 2. So the same thing I would do with the next one. I would say, all right, so 6 minus 4, is it also 2? And if it is, then I'm going to keep on going. So the way I'm going to do that, I'm going to say, all right, so there will going to be number. Now, again, this is a variable name. You can come up with your own. And since I'm starting to loop with number 1, I'm going to say, all right, so I, which again will be the index number 1 in the beginning. And now I would want to subtract it. However, I'm going to subtract it by I minus 1. So whatever you have in the index 1, obviously in the first case, and then subtract it to whatever you have in the lower index. Now I'm doing this because otherwise, if you're going from the 0 and if you're setting up the other way, then what's going to happen is that you will going to be getting a not a number because you'll actually reach outside the bounds of this array. That's the reasoning for that. And now what I would like to do is just get this arithmetic, the array. So I'm going to say, all right, arith. And let's push the number. So whatever the number is going to be. So let's say number 1. All right. Now I can do the same thing with geometric. However, in this case, instead of subtracting it, I'm just going to divide that. So I'm going to say, all right, so index number 1, divide by index which you have in a 0, and whatever the value is going to be. So in this case, this would be 3. Then as you continue looping, next one will be 27, which is obviously the next one in the line. and again, divided by 9. So this should as well return the same number. So let's do that. Number 2 will going to be equal, again, the same syntax. The difference would be here that we're not going to be subtracting, we're going to be dividing. So that's going to be the key difference here. And again, let's do the same thing where we have geo, and then we're just going to say, all right, so push. Obviously, that is our method where we can push it to array. Now let's do number 2. And again, if you want a little bit more descriptive names, you can obviously name them 1 by number 1, or I'm sorry, like arithmetic or geometric or something like that. All right, I would want to comment out right now the return of the array, and I would just want to console log what I have in the arithmetic one. So I'm going to write, okay, so log, and arithmetic is obviously going to stand for A in this case. Now we can do maybe a template literal. So we have, all right, so A will be equal to, and now let me just select my arithmetic array. So arith, that should be my array. And then also I would want to do the same thing with geometric. So let me copy and paste it. This would be G, and then we're going to write GO. Now let's see what we're going to have. So for the first one, what you notice? Well, I have 2, 2, 2. What that means that this will going to be a arithmetic pattern because each and every number is increasing by 2. However, it will not going to be the geometric because notice I have 2, then I have 1.5, and then again something else goes. Now the next one, as you're noticing for the geometric one where I have 3, 9, 27, the differences in the arithmetic one would be what? 6 and 18. Now that is not what I'm looking for because my numbers for arithmetic needs to match exactly. However, I do have the same thing here for the geometric one where each and every value in the array is going to be the same. So I have 3, the next one will be 3, and again, if I'm going to multiply this by 3, again, the difference would be 3. All right, and the last one is actually a messed up one because I have 3, 9, and then 75, which is obviously not going to be a arithmetic pattern, as well as the geometric one doesn't look very nice because each and every number is different. So my idea is very simple. So if this would be arithmetic, obviously a pattern, then each and every number in that array should be exactly the same because all I'm doing is just subtracting it. Now the second one would be the same with a geometric one. Now my key difference would be right now finding this. Well, is it possible for me to find out whether all the numbers here are exactly the same? And again, there's multiple ways how we can do that, but I actually find it somewhat easy using the set in this case. So the way I can do that, I can say like this. All right, so instead of the array, this is going to be a data structure for a new set. And what's interesting about set data structures is the fact that we can only have here unique values. Meaning if I'm going to pass, let's say 3 2s, then only 1 is going to be pushed eventually into the set. Because if we're going to be adding something to the set and the value is going to be already there, then the value is not going to be added. So it's not going to be like 3 values with number 2. It's just going to be 1 value with number 2 in this case. So I can do the same thing with geo. Again, this will going to be a set. And what I would like to do right now is change this. So I'm not going to say, okay, arithmetic push, because this is a set right now. So what we can do instead is use add, because for the set, we're going to be adding. And in this case, I'm going to say, all right, so I have number 1. So I'm going to be pushing whatever the difference is here. And the same we're going to do with geometric. Again, we're going to say instead of push, we're going to add. And now notice what's going to happen. Well, first and foremost, now it's going to say, okay, so this is going to be object offset. All right. But in my case, maybe you would want to console log actually what's happening, right? So why don't we do this? Why don't we get rid of that? And I'm going to say arith. That's going to be number 1. And then we're going to do the same thing with geo. And what do I see here? Well, I see that the first one is going to be set of 2. So if I can see that there's only 1 value in this set, that means that this obviously is going to be arithmetic in my case, because this is what I'm looking for. So if the size is going to be 1, that means that the rest of the numbers that have been added are exactly the same. So the value is not going to change. So the same thing would be for geometric one, because for the first array, the value is not going to be geometric. Because notice I in fact have three values here instead, where for the arithmetic one, I just had one. So for the arithmetic one, instead, in a second example, I actually have 6 and 18. So I know that this is not going to be arithmetic one because the numbers are changing. However, for the geometric one, all the numbers has to be 3 because each and every time as we were looping and we were trying add it to the set, since the number was exactly the same, only one number was being added. Now the last one is not arithmetic or geometric because both values are more than one. So what I can do right now is I can say, all right, so why don't we do this? So we can just get rid of the return and we can say, all right, so if arithmetic size, and what I'm looking for is for the set to have size of 1. That way I know that each and every time we're looping and adding something to the set, the number is exactly the same. So if the size of the set will be just one number, then I know that that would be arithmetic or geometric sequence. So let's say arith, since that is the name of my array, I'm going to say size will be equal to 1. If that is the case, then I would like to return the string of arithmetic. And let me just make sure that I do this correctly. Then let me copy and paste it. I can do the same thing with geo. And by the way, the difference with a set is that we're looking for not a property of length, we're looking for the property of size. That would be different. And last but not least, I'm going to be working with a return of -1 if there's no values. So I'm going to say, all right, so if neither of them are actually equal to 1, then that should be -1. And in this case, obviously, I need to change it to geometric. And yeah, sure, it's working. Now we can obviously maybe test it out even more. Let's say that we would have 10, let's say 20, then 30, and then 40. Why don't we also maybe multiply by different numbers? So let's say 2 times 2 will be 4, times 2, let's say, will be 8, and times 2 will be 16. Now I'm gonna have this one, the last one, the same because I don't think there's a difference. And yep, I do have arithmetic for the first one, and then for the second one would be geometric. And this is how we can check the math sequences using JavaScript.
So welcome back, students. I hope you have understood by watching the video how to write the geometric progression and arithmetic progression using JavaScript. So we will continue in the next session. Thank you, students.